So hi, my name is Maurice and I am a teacher, chemistry teacher, and I thought I would bring some chemistry today. Let's do some chemistry. The topic we have on board is the structure and the bond. Structure and a bond. And the structure and the bond, basically it means when the atoms bonds together, because we're going to learn the different types of the bond. We have the covalent bond, we have the ionic bond, we have dative bond, hydrogen bond. There are so many bonds. So when you join the atoms together, there's a type of a bond they form, right? So we need to know what is bonding, first of all, and what are these structures formed when these atoms bond, because when they bond, now they form a structure. We are going to look at the different types of the structures. We have the molecular structures, we have the giant structures, uh, we have many structures, right? So we're going to look at the how atoms bond to each other and what are the types of these bonds, and we do some ionic equations and the real equations. So the bonds. So basically, we can say uh, atoms bond to attain stability. Right? Atoms, they bond. Remember, I know you defined the term the atoms as well as particles of an element that cannot be split further by any chemical means, and you bend the elements. I know those are the terms you understand because we are in the class of the chemistry. So atoms, we say they bond. The purpose of atoms bonding together is to attain stability. Now, what do you mean when I talk of the stability? Stability, we say an element is stable when the outermost energy level is filled by either 8 or it has 2. But for the case of 2, then it must have only one energy level. This is what I mean. If I take an atom like magnesium is, the atomic number magnesium is number 12. All right. So I know you did this one, the first 20 elements, the periodic table, and basically all the schools, when you get to the gates of the many schools, you find the block drawn the periodic table grid with the elements filled there, explained with the atoms number, their symbols, and etc. So I hope you understand when you say this is the atomic number magnesium, and the electron arrangement of magnesium, we used to say it is 2 is to 8 is 2, 2. Look at these numbers. 2 plus 8, it is 10. 10 plus 2 is 12. This one, the atomic number. This element, we can say it is not stable because an element is stable when the outermost energy level has 8. So what we do, we either fight to get to the 8 or we deduct the values to get back to the preceding energy level, right? So, for example, this one here, with 2, we can say it is rather we lose these 2 instead of gaining 6, because at the end of the day, we need to be 2. Now, there's a case I said earlier. An element or an atom can be stable when it is 2. Its electron arrangement is 2, but for that case, then its energy level should be 1. For example, let's talk of helium. Helium, the first 20 elements, let me just have them here. I hope it is clear for you. First 20 elements. I'm going to write them in symbols because of time. So we have hydrogen. We have the hydrogen gas. We have helium. We have lithium, beryllium. We have boron. We have carbon, nitrogen, oxygen, chlorine, neon, sodium, magnesium, aluminium, silicon, phosphorus. We have sulfur. We have chlorine. We have argon. Then we have potassium. Then we have calcium. All right. So those are the first 20 elements. Those are the symbols. I've written simple because I know we are in the chemistry class, and I give you here and you still watch this video, then you love chemistry. So I know we are in the same script. I know we're in the same script. All right. So these are the first 20 elements. The way we have arranged them, they should be arranged that way, because this obtain number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and the 20. The way they occupy these numbers, it means a lot, because this number is its atomic number. So if we talk of magnesium, we know magnesium, it is 2:8:2. So we arrange the energy levels when we did that. I'm trying to explain the preceding topic before I get on to the structure and the bond so that you can understand well. Because structure and the bond, it borrows much from this first topic in Form 2, which is structure of the atom in the periodic table. The topic 2, which is the alkali earth metals. That is the structure of the atom. Which topic is that? Topic 2, chemical families, properties. All right, chemical families, patterns in properties. Then now we have the structure and the bond. So you find the structure and the bond, it borrows much from those topics. So that's why I'm trying to get back to that. But if you're still watching my videos, I've uploaded the topic of this, the first topic in Form 2, the second topic, this topic 3. So I'm trying to put things together before we get to this. So as I said earlier, there's a case whereby an atom, an element can have 2 electrons, and we say it is stable. And a good example is the helium. Helium being number 2. So the electron arrangement of hydrogen, it is 1. This one, it is simply 2. This is 2, is 2, 1. Beryllium, it is 2:2. Boron, 2:3. Carbon, 2:4. Nitrogen, 2:5. Oxygen, 2:6. Fluorine, 2:7. Neon, 2:8. Then we have sodium, 2:8:1. We have increased one energy level. I hope you were able to see 2:8:2. Aluminum, 2:8:3. Silicon, 2:8:4. Phosphorus, 2:8:5. Sulfur, 2:8:6. Chlorine, 2:8:7. Argon, 2:8:8. Potassium, 2:8:1. And calcium, 2:8:2. Right? So helium, it has the electron arrangement or the electron configuration of 2. So B2, we say it is stable because it lies in the group 8 elements. B2, it is really stable. But when we get to the lithium, it is 2:1. So for it to be stable, you can either lose this 1 to attain 2, or you add 7. So you normally go with 1, which is easier. So this one, the ion of lithium will be 2, because to lose 1. This one, it will lose 2. So basically, if the outer energy level, the number of electrons are less than 4, you deduct those electrons, right? But if they are more than 4, then you add the remaining number to attain 8, which is standard. Okay, so that's how we do it. Now, let's get to this. Remember, we said the atoms, they bond together to attain stability. So it will mean magnesium, when it is this way, it is not stable. All right. So for it to be stable, it has either to lose electrons or it has to gain. And another thing, when atoms or when elements lose electrons or gain electrons, they form ions of the charge of the number with the valency of what they have lost. What am I saying? What this nigga say? It was what I'm saying. If magnesium loses 2, it gets a positive charge. It's going vice versa. So magnesium, it can lose 2, it will be 2:8. It has lost 2. So it means for it to be to get back to where it was, it has to regain the 2 positive. So we have 2 positive. Okay. What is this? No? And why are we doing it? Anyway, let's look at the a different like chlorine. Chlorine electron regiment is 2:8:7. This one, is it easier to lose to attain 8, or is it easier to gain to get 8? When it is easier to gain 1. So chlorine, they fall, they gain 1, and they show a charge with the valence of what they have gained. So they have gained 1. If it is 1, we don't go it. So it is written this way. Another thing, it is there. These ions, they have names. The positively charged ion is called cation. It is called cation. And the negatively charged one is called anion. I know you know this. But the moment I ask you to define these two terms, I know that the country will be consumed if you are to save us. Anyway, so the positively charged ions, we call them cations. And the negatively charged ions, we call them anions. All right. Now, this one now it is stable the way it is. It is stable. It doesn't need to gain, doesn't need to lose. Already it is stable. This one it is stable. So still we are in this topic. We have not started the topic. So the atom not they bond to be stable. So if we are to bond magnesium and chlorine together, and when form them together, we get a compound. And what is a compound? A compound is a substance formed when the elements chemically combine together. All right? Chemically combine together. So if we are to combine magnesium with chlorine, so you find that magnesium has a valency of 2, and the chlorine has a valence of 1. So for them to be a compound which is chemically combined together, they interchange their valencies. They interchange their vows. 2. When you interchange the vows, you become 1. Is that true? That is magnesium chloride. So this is a compound. The elements are chemically combined. So if we were to draw this structure, magnesium chloride, if we were to draw this one, it is magnesium attached to, have your sketch, I'm going to have some nice one. It is magnesium ion here, and that magnesium, I can represent it with I can represent the number of electrons in the outermost energy level. And it's attached, first it's attached to 2 chlorines. So we have first chlorine that way. Right. Chlorine. So electron regiment of magnesium, it was 2:8:2. For chlorine was 2:8:7. This needs 1 to be stable. This needs to lose 2. So the 2 it will lose, they will be evenly distributed to the 2 chlorine atoms. One ipeane pande hii, another one ipeane pande hile. That's okay. It will give 1 chlorine here, I mean 1 atom here for chlorine to be stable. Then it will give the other group to be stable. It itself, having lost 2, it is stable, right? So we just show the 7 chlorines, atoms of chlorine. This is 7. Let's show them very clearly. So chlorine can have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. Now for magnesium, we are waiting now. We have 1, 2, 3, 4, 5, 6, 7, 8. 30. All right. So that's the magnesium. Let's start magnesium chloride. Let's have some more arranged work. We need to know the types of the bonds we form. So types of bond. Types of bonds. Types of bonds. The question I did here, there is a correction. There's a correction. That was metal and non-metal, and they form ions, and you watched me draw the covalent bond. I'm sorry. Let me just correct it because I'm live streaming. There's no correction time. Magnesium chloride. Let me just do this one. My viewers, I'm sorry for the previous question. So this one, electron regiment was 2:8:2. For the chlorine, we said it is 2:8:7. This has to lose 2. This has to gain 1. So this how when this loses 2, it forms an ion of magnesium written this way. Magnesium 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. We are in class, so we are learning. We're making mistakes, we stand, we correct one another, then we learn. That's how we learn anyway. So this is an ion, and because it's lost to 2. So if it's ion, this is how we show the structure. We show the structure this way. It has lost 2 positive. Okay. Then we have chlorine, there are 2. So we have 1 chlorine. We can either have 1 chlorine here, and the other one here, or we can have 1 chlorine here, then we balance it by 2. So can we have it here? This way. So chlorine, we have 1, 2. Let's represent the electron with the dots. Then we have 8. 1, 2, 3, 4, 5, 6, 7, 8. Here the last one is 7. 1, 2, 3, 4, 5, 6, 7. And because the needed one here to be stable, you add 1. And because there are 2, you put 2 there. Then you show a negative charge. That's the structure of magnesium chloride. This type of bond is called, I'm going to take you through the types of bonds. I will just lay down the topic. It is ionic bond. It is ionic bond. The one I had drawn earlier here was the covalent bond. So correction for that. I had to do it here because there will be no time for editing because I'm live streaming. So thank you for your patience. So let me take you through the types of bonds. That we have number 1, which is the covalent. We have covalent bond. Number 2, we have ionic bond. Number 3, we have dative bond. Number 4, we have hydrogen bond. We have hydrogen bond. The dative bond is what we call the coordinate bond. So those are the types of the bonds we have, and I'm going to take you through them very quickly, and I know you're going to learn something. So let's start with the first one. So these are the let me just have them somewhere here. This way. So we have covalent bond. We had ionic bond. We have dative bond. Dative bond is the coordinate bond, students. We have hydrogen. We have hydrogen bond. So let's start with the first one, the covalent bond. And the covalent bond, this is a type of a bond in which atoms combine by sharing their respective outermost electrons equally. So it's a type of a bond. It's a type of bond in which the atoms bonding combine by equally sharing the outermost pair of electrons. Pair of electrons. So you find that the atoms, and the many times this one happens with the molecules. So you find that we talk of a molecule like the hydrogen molecule. When we talk of molecule, there are atoms which exist like not like mono but di. All right, like hydrogen exists as di. Di means two. So you have hydrogen being written this way. Okay, so you find it is hydrogen which was bonded to another hydrogen, right? So they bonded together. So you find this one, what it needs to be stable, consequently is needed by the other one. So what they do, they equal share. What I mean is, for example, I have this duster of mine here. I have the duster here, and I have a mark pen. You have a mark pen, right? So you have a mark pen, you have your duster. And at the end of the day, we need to perform some work here. We have to do some writing, you have to rub and all that. So what we can do, we can combine together. You share the duster, I share the duster with you, you share the mark pen with me. At the end of the day, I have all what is needed. I think that's analogy is explainable as far as the chemist is concerned. You see, now that in the chemistry, we don't have motivational terms, which I may use. But that what basically means for the covalent bond, whereby we say the atoms which are combining together, they equally share the electrons. So let's see some examples of the structures of covalent bonds. So let's have a question here. Draw the following structures. Draw the following structures. Number one is chlorine. So the structure of chlorine, it is a chlorine atom attached to chlorine, the chlorine atom. So the structure will be, draw the structure of chlorine for the first one. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Then the last one is 7. I remember for the structure in the body, you can only draw, draw the outermost and level. It is okay. Not so much you draw everything, but for your learning, maybe we have some beginners on who are watching. Let's do everything. So the other chlorine atom is here. We have 1, 2, 3, 4. No. We don't do that. So first one is 2. 1, 2, 3, 4, 5, 6, 7, 8. So 2 is to 8 is to 7. 2 is to 8 is to 7. This one needs only one to be stable. This one needs one to be stable, right? So what they can do, they can only share this one because it needs one. Huyu ampe moja, 1 cross. Huyu ampe huyu, 1 dot. And at the end of the day, they are sorted. So what you do here for the plotted the outermost energy level, this one, the number of electrons we have represented by cross, it will give this one 1 cross. The number of electrons here, we have represented them by the dots. You give this one 1 dot. Then you complete the outermost energy level. So 1, 2, 3, 4, 5, 6, 7, 8. This is 2 is to 8 is to 7. Look at that. 1, 2, 3, 4, 5, 6, 7. The 8th one, it has been donated from this side here. Consequently, happens to this other side. 1, 2, 3, 4, 5, 6, 7, 8. And that's the structure of chlorine. So you find that the number of electrons, how for the atoms who are combined together, they have equally shared the electrons, the outermost electrons. All right, let's have another example. Like water. Water, yeah. Like water. I hope it is visible for you, students. Or should you form some more space? Right. Let's get some more space here. We are under the covalent bond, the first one. Don't get lost. Don't get lost. Covalent bond. So we have done for the first one. Let's have another one, which is water molecule. Water molecule. In the water molecule, we find it is 2 hydrogen atoms attached to 1 oxygen atom. Hydrogen electron arrangement, it is simply 1. For the oxygen, it is 2:6. So oxygen needs to gain 2 electrons to be stable, to attain 8 to be stable. This one needs to gain 1, and they are 2. So at the end of the day, they need 2. So what we do here, they are 2. Look at these. They are 2, right? So being 2, if this one, each one is donated 1 electron by oxygen, so 2, which will be needed here, can be needed here as well. So they're equally sharing. Look at this. Oxygen attached to 2 oxygen atom, hydrogen atoms. So oxygen attached to 2, 1 hydrogen, another 1 hydrogen, this way. So hydrogen, we have said it has 1 electron. Negative 1 electrons. For it to be stable, it just needs to be given 1. So given this way, this way. So at the end of the day, hydrogen is stable. For the oxygen, it has outermost energy level has 6. So if the number of electrons in oxygen were represented by cross, so we have 1, 2, 3, 4, 5, 6. If we represent the electrons of oxygen with the cross, they are 6. 1, 2, 3, 4, 5, 6. For it to be stable, it needs to gain 2. So the 2 it's going to get is the 2 dots it has been given by this hydrogen and the other hydrogen. This one and this one. All right. So in that case, the hydrogen is stable. You need to gain 2. This one as well, you need to gain 2. Oxygen is stable. So they have equally shared. And that's where now the term covalent bond comes in. So that's a type of a bond whereby the atoms which are combined together, they equally share the electrons. It's as simple as that. We can have as many examples as we can, but because of time, let's go on to the next one, which is the ionic bond. If you have any question in the comment section, let me know. Let me know. Let's go to know where you watch us from. Maybe your school, your alumni, maybe of the school which was my neighbor's school, or maybe my sister's school. Okay. Anyway, covalent bond. Next is ionic bond. Ionic bond. And ionic bond is a bond between, this is a bond which involves metals and non-metals. Metals and non-metals. And what exactly happens after they bond together? They form ions. They form respective ions. And a good example, let's look at the sodium chloride. Examples, let's have sodium chloride. Sodium chloride is a compound which is made up of sodium, which has an electron arrangement of 2:8:1, and a chlorine, which has an electron arrangement of 2:8:7. So you find that this one, what the other one needs, maybe it is what the other atoms is losing. right? So what you are losing is what gained by the other electrons, other atom, right? So what happened? This needs to lose one, this needs to gain one. So what is lost here is what will be gained here. At the end of the day, they'll form a bond, a compound which is chemically combined, but there will be ions. So this one will lose one electron and form ion of sodium written this way. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So it lost one, and when it lost one to form a positive cation or positive ion that way. Then this one will gain one, and it will be this way, chlorine. Let me send the electron with cross dots. 1, 2, 3, 4, 5, 6, 7, 8. We have the last one. 1, 2, 3, 4, 5, 6, 7. So we lost one here, that's why we get these charges. So we are gaining this one electron, and it is not a dot now, it is a cross because it's been from this side. And you have to show you that too, because it's a compound anyway which has been formed, and it is one thing now, it's no longer existing as one. We have a charge there. That is the structure of sodium chloride. That is the ionic bond. That's an ionic bond. All right. You're going to look at the structure they are formed. Is it a molecular structure? This is a giant structure. What are types of forces which are holding the particles together? Are they the weak particle, weak forces of van der Waals forces of attraction? Is it a metallic bond? The effects on the heat on them. Those are the things we're going to look at. So that's the structure of sodium chloride. We can have another example. Here. That is, let me check my reference book, magnesium oxide. Magnesium oxide. Magnesium oxide is made up of magnesium and oxygen. Magnesium electron arrangement is 2:8:2. Oxygen is 2:6. This has to lose 2. This has to gain 2. Can you see that? What is lost here, it is what is gained here. When they interchange the electrons, they form a compound. So magnesium will form a compound, an ion, which is cation. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Then it has lost 2, so it is 2 positive. Oxygen, it has gained 2, so it is 1, 2. All right, we get a big structure. This one. So it has 1, 2, 3, 4, 5, 6. So it has to gain 2, and that 2 is what has been lost here. The number of electrons here, we are representing them by crosses. Show cross that way. You show it is an ion which has been formed, this 2 plus. And this one will be 2 minus. These are cation. These are an anion. These are cation. Now this is a ionic bond. Ionic bond. It is as simple as that, students. It is as simple as that. The next bond we are going to look at is the dative bond. What we call the coordinate bond. The coordinate bond. Number 3 now. Dative or coordinate bond. Coordinate bond. Now, when you talk about coordinate bond, now this is a type of a special covalent bond. It's like the atoms which are combined together, they are sharing the electrons, but not equally, as we have seen in the covalent bond. In the covalent bond, they are sharing electrons, but equally. if you're talking of, for example, a molecule like hydrogen, we find one atom has one electron, the other one has one electron. So for them to be stable, one is giving the other one electron, the other one consequently one electron. So they're equally sharing, all right? But for the dative bond or coordinate bond is a bit different because the atoms which are bonding, yes, they are sharing electrons, but not equally. You find there is a one atom which has contributed a lone pair or a pair of electrons, all right? And we're going to look at some of the examples of those compounds which forms the dative bond. A good example I think we normally use even in our course books is the ammonium ion. So let's bring the term, the hydrogen bond. It's a type of a bond, right for some of the friends. It is a type. It is a type of a bond. It's a type of a bond in which the shared pair of electrons forming the bond is contributed by only one atom forming the bond. So can you explain this grammar in a chemistry? It was mathematics, I would say mathematically. So it's a type of a bond in which the shared pair of electrons forming the bond is contributed by only one atom forming the bond. Look at this, carbon 2 oxide. Example. I'm just going to have two examples, that will be enough to explain everything. So carbon 2 oxide. Carbon 2 oxide, the structure, the symbol is CO. And carbon, the electron arrangement is 2:4. And the oxygen electron arrangement is 2:6. So you find oxygen has to gain 2 to be stable. This one has to gain 4. All right. So you find this one will give this one how many to be stable? It will give this one 4 for it to be stable. All right. And this one, because it's 2, it has to be given 2. So this is 2. So I'm giving you 4, you're giving me 2. Right? So to me, there's another pair of electrons. Now, what is called now the dative bond or the lone pair, which is pentane, which has been given by one atom alone. How will the structure look like? Look at the structure. It is carbon. Attached to another atom of oxygen. So you said carbon will give oxygen only 2. So if the number of electrons of carbon represented by X, it will be 1, 2. Carbon has given oxygen 2, and the oxygen is stable. Carbon has been given 4 by oxygen to be stable. So if you represent the number of electrons of oxygen with the dots, then this will give 4. 1, 2, 3, 4. Okay. So you can complete the circle. So for the carbon, the outermost electron was 4. 1, 2, 3, 4. For oxygen, the outermost energy level was going to be 6. The dots now, remember. 1, 2, 3, 4, 5, 6. So when we add now the 2, it is stable. 1, 2, 3, 4, 5, 6, 7, 8. So the first energy level was what? For oxygen was 2, 1, 2. This one was 2, 4. So we'll look at this one. This X for carbon can cancel with this one. They have shared that equally. This another X can cancel with this, but we have these two. I hope you can see this one, my students. My goodness. I hope you can see that. These two. This is now what we call the lone pair. Lone pair. In other terms, this is the dative bond. Dative bond. In other words, this is the coordinate bond. Coordinate bond. Yeah, coordinate bond. That's how it looks like. So you find it's a type of bond in which the shared pair of electrons forming the bond is contributed by one atoms from the bond. So this one, if we remove this one here, that will be a covalent bond. In other words, you say it is a type of a covalent bond. It's a type of covalent bond. They are shared by one electron, they are given by one atom, not like the other. All right, so that's what it looks like for the ammonia. I mean the carbon 2 oxide. Let's do for the ammonia. I'm mentioning ammonia because this is what I'm doing next. Ammonium ion. Ammonium ion written this way. Usije ukasahau ammonium ion. So you find it is nitrogen attached to. So we have nitrogen, which is nitrogen is here, number 7. With 2:5. Then we have hydrogen, which is 1. In the case here, they are 4, meaning they need 4 to be stable. This one, they need 3 to be stable. Okay, so it is nitrogen, attached to 4 hydrogen atoms. So we have the first one, we have the second one, we have third one, we have the last one. This is hydrogen, this is hydrogen, hydrogen, hydrogen. Okay. Now, this one has 2, needs to be given 3. Till bond with only 3. And this one needs to be given 4. Okay. So the one which are going to bond with nitrogen, there are 3 of them. So this how it will happen. It will bond nicely that way, but one will be given free that way. Okay. When you count the crosses, for the nitrogen is 5. All right. Don't get lost. Outermost electron for the nitrogen is 5. Let's see for the fact that crosses 1, 2, 3, 4, 5. It needed 3 to be stable, so it has been bonded with 3 hydrogen atoms. It has been stable. For the hard hydrogen, this one has bonded with this one as it is stable, this is stable, this is stable. But this one has not bonded. It has been given free, a pair of electrons free for it to be stable. And now this one is what we call now the dative bond. Why am I pointed it this way? We can plot them this way. This is what we mean. We can have nitrogen this way, attached to hydrogen, 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 hydrogen. So the one, this one, which is dative bond, we can show it as an arrow. That way, this is the dative bond. Dative bond. Okay. These are the rest, they are covalent bonds. These are covalent bonds. Covalent bonds. That it can as well happen to this one. We show that way, then this one, we show the covalent bond. That's what we're talking about. So that's all about the coordinate bond. The last one, students, is the hydrogen bond. Hydrogen bond. hydrogen bond, and under the hydrogen bond we say is an intermolecular force in which it's an intermolecular force in which the electropositive hydrogen atom of one molecule is attracted to an electronegative atom of another molecule. Look at that. Hydrogen bond, it's an intermolecular force in which the electropositive hydrogen atom of one molecule is attracted to an electronegative atom of another molecule. This is what we mean. A good example for this one is the water molecule. Is what we call the water molecule. So intermolecular force in which the electropositive hydrogen atoms, one molecule. So we are talking of the water being the whole thing. Look at this. This is water, which is a molecule. All right? Molecule is a molecule. Being a molecule, in that molecule we have the covalent bonds which hold the particles together, the hydrogen and the oxygen. So we can show them, and we have the positive, the electropositive atoms and the electronegative atoms. Right. So for this one, we have both the electropositive, which is the hydrogen, of course, and the oxygen is the electronegative. So it will be like this way. We have oxygen. Let me plot it up here. We have oxygen, which is electronegative. We plot it that way. Electronegative, and it's attached to hydrogen, which is electropositive, and another hydrogen, which is electropositive. This molecule is this one. We are showing the electropositive and electronegative atoms in this molecule. So this molecule may be attached to another molecule of water this way. We have water. To show the electronegative ions, positive. Now the bond between these two, the electropositive atoms and the electronegative atoms, this one here is what we call the hydrogen bond. I think that is self-explanatory. It's an hydrogen bond, intermolecular force in which the electropositive hydrogen atoms, that's why it's called hydrogen. Electropositive hydrogen atoms, this is the electropositive hydrogen atom of one molecule. This molecule of water is attracted to an electronegative atom of another molecule. So another molecule we took as water. We can get another molecule as well. There's so many, exonium, etc. There are so many. So the bond between these two, electropositive and electronegative, this one here is now what we call the hydrogen bond. That's all about bonding. The next lesson I'll be looking at the structures. We are going to look at the molecular structures, the giant structures, the structures of the carbon, the allotopes of the carbon, that is the diamond, the hexagon, the graphite, and what the amorphous carbon. Right? That's what we'll be doing next. So for now, thank you so much for taking your time and choose the Goma schools for you to learn. Remember, the Goma School is the school of pure mathematics and chemistry. Thank you so much. Make sure you subscribe